Welcome to another episode of Generating Conversations. Today we have Vik Singh, a Cal alum and thought leader in AI applied to information retrieval. Previously, Vik was a director and architect at Yahoo, where he led the development of their enterprise search offering. He left Yahoo to launch Infer.com, where he used machine learning to generate sales leads for customers. Vik sold Infer to Ignite Technologies in 2017. Since then, Vik has been involved in a lot of things, including teaching a wildly successful course on data science and entrepreneurship at UC Berkeley, and I will say I was a barely helpful co-instructor in that class. And now recently, Vik has been playing with some cool new technologies around high-performance multimodal search. So with that, I'd like to welcome Vik, and we are excited to have you here with us today.
Great, thanks for having me. And you were very helpful in that class, so I have to say.
It was a fun class. We had, I guess, speakers from all over industry. And both on the technological side and the business side, and a ton of undergrads got a chance to meet with top executives and learn about how the space had evolved. So, and I showed up for class.
We should do it again, but then have generative AI do the questions as opposed to students asking the questions. Yeah. That'd be fun.
All right. With that, you've been spending a lot of time with AI founders and entrepreneurs. What are the trends you've seen in the startup ecosystem around generative AI?
Yeah, I mean, there's a lot of activity. I mean, you see it in the fundraising announcements. You see lots of really smart people jumping into the space. So that's great. So you see a lot of innovation in a lot of different places. People trying to leverage generative AI for applications to improve the infrastructure, all of which is early days, and so there has to be a lot of work there. I think the challenge I'm seeing is, it's tricky on the business model, I would say, more than maybe even the technology side. Mainly because you have this foundational model that's out there that gives you this like magic machine that you can just pass in prompts and get answers from. But the challenge is that most of these applications I see are kind of like thin wrapper calls to this foundational model, and the data that they're pushing into that model isn't necessarily data that they might own. Right, it might be like a plugin to Salesforce, and they take something out of sales and they put that into some prompt and they get some response back, and so it's not as easy to defend in terms of having a moat. So I think where you're seeing a lot of opportunity is not so much on the enterprise application side yet. We'll have to wait a year for the sales cycles to kind of take place, because they do take longer to sell into, and enterprises are still learning about this stuff. The buyer isn't fully educated on how all these things can work. There's a lot of challenges with respect to security and like generating random words on their homepage that might cause legal issues. Like there's a lot of things that they're navigating. But where you're seeing a lot of interest and use cases right now is really in the consumer side. So you see like things like character AI, which is very popular. Obviously, ChatGPT itself, Perplexity, others, where you basically have this application that anyone can go to. It's not necessarily tailored to a company or a business. So you're more in the consumer side or even B2C side, and people can leverage it and get really great value from it. There is some interesting things happening, I think, on the business side with respect to creativity. So like Typeface and those types of players, which are helping you kind of create content. Firefly from Adobe. Like there's some really cool things that people are doing there to help people express their creativity, create campaigns, create articles, create knowledge bases, which I think is really cool. But I think the pure enterprise, more B2B side is still extremely early and difficult to defend. And so, I have some ideas on where I think startups should look for inspiration. I actually think if you look at the offerings, like the applications that are being created by big companies, and you compare those on average to what's coming from the startup side, I actually think the larger companies are producing better applications. And it's weird to say this because 10 years ago, when I started, Infer, or actually longer than that, and probably even, it's always been the case that startups have always kind of been on the cutting edge, and big companies were these slow dinosaurs who couldn't catch up to them. And so the startups led the innovation side. I think that is not necessarily the case today. Like if you look at some of the offerings, like for example, what Salesforce is doing with their Einstein bots, to what Microsoft's been doing, with respect to their Power Virtual Agents and all these various platforms for building on OpenAI. They have this whole OpenAI platform you can build on top of Azure Studio, which is pretty amazing. You have Snowflake coming out with Cortex today. You have Databricks with all their various AI offerings that are coming out and things that they've already produced and their acquisition they did recently. There's a lot of interesting innovations happening on the big company side, and I really encourage entrepreneurs to like watch these videos. I mean, they're very enterprisey, so you kind of have to fast forward a lot. But like, if you actually look at their product demos, they're really well thought out. Like, if you look at, for example, Microsoft's Power Virtual Agents demo, they're not only just doing the text-to-text stuff, like the normal chatbot stuff. They're doing like the phase 2 of chatbots, which is what Andreessen Horowitz talks about on their blog, which is the workflow side, where you can like say, hey, I want a hotel reservation, or no, I actually want a cruise reservation, and I want it in October, but I want it in the week where it's not raining. And it'll actually build the query plan where like it's going to hit the weather APIs and get the weather data. It's going to hit your SQL database and pull out the reservation tickets, and it will figure out which ones match it. And then it'll say, oh wait, I'm missing something in the query. I don't know where you're departing, what city you're departing from. So it'll actually refine and ask you a question where you want to leave from, and then put that information into the query and then give you the answer back. And so, it's much more buttoned up, and I think it's because the large companies have the data and they have the customers, which startups don't have. So their use cases are just much more specific.
So your comments are interesting. I'm now a little confused, because in some sense you're saying that it's hard to sell to big enterprises, which is what we're hearing as well. That they don't have the sophistication to make the right decisions yet, or they're still trying to figure out what is the right paths to pursue in the generative AI space. But then you're also saying that the big companies are really kind of leading, which again is rare. But maybe leading not just in having the technology, but also maybe having the right product shaping. But then the products that you're highlighting tend to be more enterprise oriented. Is it maybe that they're leading in the enterprise direction, or is it? I guess I'm trying to figure out where is the world heading? Is the future of generative AI at the enterprise, or is it the consumer?
Yeah, I mean, so the big companies are technically fueling both sides. Like, they fuel the consumer side because they have the platform, they have the foundational models, they host a lot of things that a lot of these consumer apps are built on. But on the enterprise side, yeah, they're much deeper because they already are engaging with those companies on other things that they sell, right? Microsoft sells SQL Server, Databricks sells all their various ETL solutions. So they already have these customers who want to do intelligent things with their data. So it's a natural thing to upsell them into this whole LLM game, because they're seeing all the attention OpenAI is getting. They're seeing all these amazing use cases. So they're going to ask Microsoft and Databricks and Snowflake, hey, what can I do with AI? And so they're in the natural position. Like, they're right there front in line to get them on and try these solutions out. But they also get to hear the use cases and make it very specific to what they want. And I think the startups are sort of pretending and thinking what these companies want. But I think it's not as buttoned up as the large companies. But that doesn't mean that startups can't exist and it's a big company world and we're all screwed. That's not the case. I think the one thing that's always been the case with big companies, and I think big companies will admit it as well, is that they tend to boil the ocean. They tend to be very broad. They tend to try to solve everything for everybody. And that's where you run into deficiencies. That's where you run into solutions not being good enough for a specific niche or a specific type of customer or a specific type of user. Or it's not open enough, or it works with other solutions really well because they tend to like make everything their way, like everything has to work with their platform. And so that's where there's opportunities. But I think if the startups are creative enough, I would be looking at the big companies and watching these videos and learning and building solutions that can do it a little bit better, a little bit more specific, because they're going to boil the ocean and mess it up, right? Every big company does this eventually. And the nice thing is, if you do it this way, the big company is supporting you. They're kind of like your free marketing engine, right? They're putting tons of dollars into the category creation because the category is still very early. So we don't know what's going to win, but you're not going to outcompete these bigger companies who have the trust and have the money and the advertising to be able to create these categories. So you want to ride those coattails, if you will. And so I think there's a lot of opportunity and inspiration around that. And I don't see a lot of startups thinking that way because it's very contrarian, right? Startups have to think differently than them, but I don't think that's the case. I think we need to work together a little bit more.
Yeah, I do wonder if maybe part of that is that when you're trying to build LM technology, you're sort of you're both selling to the top of the company, like, this will be an enterprise ready solution, but also you need to sell to the user, the end user more, because they're the ones who have to communicate. Yeah, we need this LM technology in this use case that the leadership didn't even imagine possible. And so maybe that makes sense. Some of my students are doing work in generative AI, and it's kind of similar mindset that the trick is to get visibility even in the consumer space to help build the visibility of the commercial solution, which is clearly what OpenAI is doing well, is as well with ChatGPT. So capture the minds of everyone and then build into the enterprise. All right, so I guess when we think about where things are headed, you're following the space. What around the LLM technology are you most excited about, or generative AI broadly? What are the kind of trends at the technology level you think will enable the next generation of startups?
Yeah, there's a lot. I mean, there's a lot of good things currently in market that are getting leverage, or we're learning how to leverage it properly. I mean, RAG is thrown around everywhere. I was just talking with a large company who's obviously building lots of AI solutions. They're focusing more on sales data, and their approach is very RAG based because it scales. They don't have to build models for every single one of their customers. It works really well. And so there's a lot of you can give the end user a little bit more control because they can control the prompting. They can control the data sources that kind of feed into the prompt, that pad the prompt. So I think, but it's also very hacky. No one really knows how to do it well. The best practices aren't really well understood. How you evaluate it isn't very well understood. And, companies want to feel like their data is being leveraged in the system somehow. That's what gives them their uniqueness. But is it RAG? Is it fine tuning? Is it a combination of both? What's the operational cost of running it? But not just running it, but how should you even create it? Because these things are changing so fast. It's making every a lot of companies want to build these chatbots, and there's a trillion ways you can go about building a chatbot today, and you can go the Pythonic, 20 million open source libraries out there. You can go try to build it that way and hire a contractor or something like that. Or you could try to use these low code, no code ways of doing it that are being offered by the bigger companies. It's kind of a free for all at the moment. And so I think a little bit more evaluations and understanding of these various solutions and best practices is necessary to kind of get that going. I think the other part is performance. I think speed is everything, and it would enable ridiculous use cases if you can get the speed to a place where it's appropriate. So right now, you have a speed problem and you have a reliability problem with leveraging the foundational models. It could take upwards of 10 seconds. It could take multiple retries to get a response back, which is really pushing it where, in this, especially for consumer applications, which I think is where you're seeing a lot of interest. When I was at Google, we were told never to go above 200 milliseconds for a search response, and, now we're okay letting users do 10-second plus responses. That sounds crazy to me. It's blasphemous. And I think we're accepting it because the quality of the result is so good. But eventually, people are going to want faster responses. And in fact, you can maybe even attribute that to today, because I think there was a dip in OpenAI traffic, the month-to-month trend. And that could be the case where it's just too taxing. Maybe you have a very simple ask. Most asks you have are simple, basic requests where you don't want to write a long prompt. And you probably also don't want to wait 10 seconds for an answer back. And so it just adds to that additional penalty of using these solutions. But it also opens up other things, not just the consumer kind of happiness. It's also, from an enterprise perspective, very important. So, for example, I think Snowflake came out with something. It's very similar to Instabase, actually, where you have a bunch of documents, these PDF documents, and you want to be able to extract information out of these documents. And so they give an example of this, where you can pull out these various fields out of this PDF document. You can pull out the price, the invoice number, all these things. It's pretty magical. You don't have to train an LM. You don't have to create your own parser, if you will. You just use the LM. It just works really, really well. The challenge, though, is that these LMs are still kind of slow in doing it. And these companies typically have, if you're using a Snowflake system, right, that means you're using a warehouse, which means you probably have a ton of data in that warehouse. Yep. And so you can imagine like it's like per record you have a potential invoice or a PDF of some sort. And so you're not just doing this on a one-off PDF. You'd ideally want to run this over all the rows in your database. And that would be incredibly cost prohibitive. And it would be incredibly slow. You probably have to wait years for it to finish. I mean, like literally. And it'd probably be really difficult unless you parallelize it. And even if you parallelize it, it's tricky to do with their syntax because they want you to do it the SQL way, and I don't think it does that fully. And so if we had a hierarchy, though, like you can imagine like we had really fast LLMs, and you have like the foundational model, which is like the big slow but just does everything well at the bottom. Then if you ran it through that example, maybe these like faster LLMs, and maybe not even LLMs, like what if we went back to like old school machine learning models? Like, I mean, that sounds blasphemous, but like these things are like tried and true. Like we know how to do binary classification on text really, really well. And we just kind of threw all that away once LLMs like took off. And but you're never gonna beat the performance of one of those models. Like it is like you could do logistic regression like on a really bad computer. I think using scikit, like 12,000 predictions per second. I mean, like you're talking like ridiculous, like in terms of performance compared to LLMs. And so ideally, like if the naive model, if you will, does well on those tasks that you are running through it, then it should just run it through that, because if you have a lot of workloads or a lot of records, that would make sense. But you can imagine like maybe like it checkpoints itself every once in a while, and it looks at the predictions it made, and maybe it checks with the foundational model, hey, like how am I doing on this one, these random ones? And maybe it missed a couple, and if it did, then maybe that turns into training data for the naive model. But maybe like, you know, for ones where the confidence of the naive model is low, maybe you run that to the foundational model. Like just that whole hierarchy I think is really fascinating. You know, people talk about semantic caches where you can take like, especially in databases where you have lots of records with data duplication or similar values, like that should all be in that stack. You know, similar to kind of what you have in computers where you have L1, L2 cache and all those things, and then it kind of goes down eventually to disk. Like you need something like that for the LLM side, if you will. And I think that would open up a lot of use cases.
Yeah, it's interesting that you talk about kind of the excitement around RAG, this integration with data, and you're spot on that like where LLMs are emerging, you know, as a key solution point today, and probably where they will go in the future is this, you know, ability to retrieve and then generate from data, which I guess relies on good retrieval, which is something you've worked on for a while. And you know, it's funny to watch the LLM space today where people are like rediscovering a lot of ideas that, you know, have been around forever and how to retrieve information. I want to actually ask you a bit about that in a moment, but you know, building on if you could retrieve the right information, how to put it together. I was in a meeting with my students today, and we're like, what's the best way to do RAG? No one really knows. And we're doing RAG research, and we're like, what, should we do map reduce RAG? Should we fold over the data? Should we stuff everything in a giant context? Is a bigger context a better solution, or lots of looks at a smaller context? There are so many unknowns that projects like Llama Index have emerged to give us the framework to explore the space of unknowns. But I don't think there's the set of solutions yet for what is the right path to that space of unknowns. And as you pointed out, you know, speed is something that I guess we've tolerated because LLMs are chat, and chat, you're talking to a person, obviously, and persons are slow when you chat with them. But, you know, we want to use LLMs to do more than just chat with the person. We want something to, you know, solve problems. Yeah, that asks for a very different latency than the technologies we're building. And certainly there's an opportunity to hybridize, you know, the classic learning ideas with contemporary LLMs in a way that gives us that experience. And actually, so RAG is kind of neat because it does that. RAG being retrieval augmented generation, which ironically is a specific model, but today being rebranded as kind of the broad class of retrieve and then read to answer questions. The retrieval part has gotten a lot of attention, and you have an interesting background in working with search systems. Maybe you could talk a little bit about what's going on in the vector search space. Have we just rediscovered search again? Are we doing it right? Are we doing it wrong? What are the opportunities there?
Yeah, I mean, some ways we have. We definitely have rediscovered search. I think there's a lot of lessons from search that are being applied. I'm seeing it now. I think with the earlier versions of vector search, it kind of felt brand spanking new, like the Chroma DBs and the Planck. Like, hey, here's vector search, and I was like, you know, that's been around for a very long time because we have to vectorize things as well in classical search indexes and dot products on these like vectors, which were just like TF IDF weights, you know, like that all kind of existed before. I think the difference is though is that the vectors, I think here can be much larger. But I think the first wave of vector search was really about like, you know, LMs are like amazing, but we need to save this in some way where we can do these things really quickly. And so vector search was very natural for this because of the embeddings that you get from these models. And so you could save these into their special database, and you can do these lookups fairly quickly. I think the first wave of solutions I saw around this may have made some interesting assumptions. So for example, a lot of times, like when you chat with a chatbot, and let's say you're doing like a RAG thing with the chatbot. So it'll vectorize your prompt, right? Or not, like, I guess what you entered into the chatbot, like what you're interested in. It will vectorize that and then, do its kind of nearest neighbor search in the vector search, pull the top results, somehow take the text from those, we don't know how exactly, and then stuff that into a prompt that it asks the LLM to answer the question that the original query was. The challenge I had with that was a lot of the implementations I saw, they would just vectorize the prompt that the user gave, but when you vectorize it, you're throwing away all the keywords that the user gave, because you're basically washing it out over this 384 dimension vector. And like, where do the keywords go? Like, those keywords are actually still very useful, And so I think now, and I saw some like posts from Microsoft like, hey, did you know that hybrid search is actually really good? Where you if you don't throw away the keywords and you do vector search and you combine it together, you get better performance. I'm like, yeah, no, duh. Like, that's always been the case. Like, why are we throwing the words in the first place? I didn't understand that. So I think now people have kind of sort of moved towards a hybrid search model, where you use vectors, but you also use the query to search. Now, the challenge with all these solutions is a lot of times these vector search engines are separated from your primary data store, because you still have to do a lookup in the primary document store you have to pull the information you need to present it back to the end user or to be able to RAG. And when you have these systems in two different systems, you're a database person, so now you have to worry about consistency. You don't have transactions within the same system. So then you had things like PG Vector come out, and it does it within Postgres, which was kind of an improvement. And I think over time, all the database systems are going to have vector search built in, similar to how these systems have full text search indexes pretty much built in. And so it's just going to be there everywhere you want. Databricks is offering it, Snowflake is offering it. I think they even made the embedding like a new data type, like a SQL data type, which is kind of interesting. And so it's getting integrated very natively, or will at least feel very native. So that's good. That was also a challenge I had with some of the standalone vector solutions. But then the other challenge I think people are going to start running into is what you're mentioning, which is the retrieval part, where we're sort of okay, you have some keywords, maybe you have this vectorized thing of your prompt that you provide the query, and then you use those two things to get the nearest results to those, and you get those nearest results. The challenge I have with that is that a lot of times that's not the primary way you should be ranking that content. Similarity is only one feature in ranking, even in web search, right? It is only a piece of the ranking function. There's a ton of other things that matter. Freshness, like what was the date of when that information was published? All those types of things. So you can imagine, let's say, the classical example, you're on Amazon and you're on some product page and you want to find other products that are like this product. It's a great example to use, like a vector search, right? You can maybe vectorize that whole, everything about that product, go find everything else that's like that. But what you'll end up finding is that you might end up with some weird results, right? Because you threw away everything else that mattered. You threw away reputation. You threw away the store and who that store was and how much they sold and all these things that are really critical to determining what are good products that are related to that product. Or even the comments or when it was released. You probably want to find products that are kind of similar in release date because you don't want to pull something that was 20 years old. And so it's kind of left to the end user. It's it's your problem, and that is a really hard problem. And so ideally, you wouldn't even need to think about vector search. If LLMs were fast enough, then you could argue that the LLM should just do the similarity for you, right? You can say hey, here's a product, and here's a store, here's how much they sold, here's the date, here's a description, and here's another product with all those similar attributes. How similar are they? Is this a good match? Why not use the LLM to do a much more advanced similarity versus this, really rudimentary cosine similarity approximation that we're doing with vector search today? I think that's what people actually want. And so we're still in the infancy stage, but we need solutions that do more of that. And then you get ranking for free through that because you can do that pairwise, and like it'd be amazing. But yeah.
Interesting. So if we think of something like Pinecone, which is a pretty successful vector store, so maybe an example of what many have described as a successful company up to this point. How does that fit in kind of your worldview of the space of technologies, and maybe how as a company is it on the right path or the wrong path?
Yeah, I mean, I think I kind of group Pinecone, ChromaDB, Weaviate, a lot of these various platforms in kind of the same, like they kind of face the same opportunities and challenges. I think the big challenge that they face is one, the space is changing a lot in terms of the requirements. Like, we were mentioning earlier, like, do we even need a vector search? Like, should it be something that's maybe like if you had fast enough LLMs, like the LLM could be the similarity function, the LLM could do the ranking, the LLM could do the retrieval. Like maybe there's a way to bundle that, and putting vector search there kind of just complicates things. Like it gives people this feeling that they're storing their data in a smart way and they can retrieve it and do RAG. But when you start running into the issues, once you start deploying it, you start seeing quality issues and ranking problems and all those various issues. Maybe we need something that's a little bit smarter, but that ends up rethinking the whole stack altogether, and maybe we don't need vector search. So some of that stuff isn't future proof. So I think those challenges are hard to kind of foresee, how people actually build their apps and what they need and how the LMs change and how they evolve and how fast they get. If they're fast enough, I would argue you probably don't even need a vector search if they're really quick. But because they're slow, vector search is really helpful. I think in terms of the other challenge they face is kind of the other thing we mentioned, which is the bundling that's happening with the databases. Postgres and all these other various solutions are just going to include it. Databricks is offering their own, and Microsoft's offering theirs, and like there's so many different vector searches. And so wherever your data is, like your existing primary document data store is, you're probably going to be incentivized to use the vector searches that are available around that stack. But at the same time, Pinecone and ChromaDB and all these other ones, they have that kind of front start. Like they got out pretty quick. They're also well integrated with LangChain and all these other like Llama Index and other kind of various open source libraries. So they're getting tons of market share. And so even if those solutions come out with bundled with Microsoft solutions and Databricks, they have to compete. And switching costs is still switching costs. Even if those other solutions integrate with LangChain, it's not that simple to switch, right? Because your data is now stored in that vector table, and then you got to worry about migrating everything, and then making sure the embedding model is the same, and all those issues that you run into. So they definitely have a huge advantage. I also think it's nice that they're at a layer of the stack where they're kind of like a infrastructure play. So it doesn't even matter. Like a lot of the startup challenges that we see are really on the application space, right? Because you don't know, like it's hard to build moats there. But if you own data and data is being stored in your infrastructure, there's a clear business model for storing for that, charging for that, and it's you're a shovel for someone to go find gold. You don't have to be the one who ends up creating and finding the gold for them. So it's a nice place to be in the stack. But I think it's a tricky space. Like I don't know if the winners are the ones that are the winners today are going to be the winners in the future. I also think they have some like challenges being useful for everybody. Like so, for example, I was talking with the Twitter folks, and they really care about vector search and doing semantic search. But given their volume, like they just couldn't get it to work with any of the vector search technologies that are out there. And so will that require them to build their own in-house solution? Will that in-house solution end up being the solution everyone else uses if they open source it? So I think there's still a lot of work to be done to see like, what the right approach is and the right model and the right scalable model is for future app development.
It's funny you say that. One of my students were working on an archive RAG system for archive papers, since I can't keep track of what's going on. And I'll enter, what's going on with long context. And that's not enough for a search. And they get results and they're kind of garbage. And the student's like, why are they garbage? Like, well, all the results match. And I was like, well, how do you sort the results? Well, by how similar they are. But I didn't say much. And they're like, well, all right, so what else should we use? And well, I mean, what's the most relevant document? What's the most important document? Like, well, how would you know that? Like, would you have a citation graph? Like, how would you use a citation graph to figure out what's important? Like, PageRank? Like there are algorithms we've been developing for years to improve relevance, and the answer is relevance isn't always about semantics. It's often context that's outside of the scope of the words. And it's funny to see how that got lost. And then, Postgres and having relational systems being the vector store, I've heard great things like, did you know you can now not only do similarity search, but you can condition it on price or region or availability? Like, yes, yeah, the basics are also important. And yeah, so I think you're spot on. Like I think, when I look at the vector store space, I was like, this is old. Why is it coming back? And it's coming back because it is important for these technologies to be able to find important, like, related information. But we're viewing the notion of related or important information through the lens of modern AI, which is vector relevance, and maybe not through some of the more classic, but perhaps in many cases more important criterion, like just overall relevance. I don't know, citation counts, clicks. Is this the right price for the user's looking for? So yeah, it's neat to see all these things coming together. And I agree with you that in the next few years, I imagine most systems that store data will have a way to retrieve by vector relevance as well as the other methods. So, all right, I guess I love to talk about technology, but we should talk about business too, because after all, many of these companies are not just building cool technologies, but theoretically trying to make money at some point. So maybe could you talk through what you think is kind of the right strategy for generative AI startups? Should they, take the classic product market fit worldview, or is there how should they approach business today?
It's tough because it kind of goes back to what we were talking about earlier, which is, it's hard to build a moat as a startup. And hopefully you can find a product that has product market fit, but it may not have enough defensibility. It may be hard to price up. It may be so competitive, like with other various similar offerings, that you get undercut on price. So it is very challenging to kind of build a go-to-market plan around this, and I think we're going to kind of watch and see what kind of pans out. I think it's a little bit easier for an infrastructure player. Like if you're lower down the stack, it kind of makes sense. You kind of pay for your serving costs and the uptime and all those types of things. That makes sense. I think on the application side, it gets more dependent on what application you're trying to build and who you're selling it to. I think the a kind of a broad thing that could be helpful is, like, if you look at some of the plays, like for example, what Hugging Face has done in the community that they built around their models. And some people say, oh, what they've built, they don't really have any tech there. They're just kind of like an aggregation place of GitHub for models and blah blah blah. But that's incredibly valuable, because now they've become the one-stop stop for getting models and sentence transformers. All those pip libraries that people use are all kind of interfacing with a lot of the work that they've done, and so they are in every stack. And so I think that is very, very powerful. Similar to how GitHub is extremely important and powerful in the development world. And so I would think a lot about your community, because I think that is a moat if you get a community. And that's why I think the open source path, like the Hadoops and Clouderas, and I think Gorilla and others you guys have been looking at, is a very smart strategy, because you not only have great technology getting developed, but you have a great community getting built around it, which creates product market fit, but it creates something much deeper than that, which is like this allegiance and loyalty and this mass adoption of your solution. And that is very hard to fight against. Where a competitor comes in and maybe they have a better solution, or maybe they price you better, but you're just more known. You're just more trusted. Like, you have a better community. So I would think a lot about the community you want to build, not just the technology and the use cases. The use cases matter in terms of what kind of community of people you want coming to your product, but I think about what kind of organic community you can build, built on trust, built on open source if possible, and build it that way. And that's also a great way for startups to de-risk what they're building, because if their community isn't getting built, if there isn't a lot of stars and forks of your project, that's a very good signal for you to know whether it's worth going deeper down that path. So you get a lot of free signal, and you don't have to raise a lot of capital and learn it the hard way of whether your solution was the right approach or not. So that's one thing. But happy to go more specific on specific businesses. We can kind of talk about specific startups or something to make it more concrete. But I think in general, I'm a huge fan of open source and community building around what you're building here.
Makes sense. So I like kind of your worldview on community. To me, that's probably one of the biggest pieces of advice I've taken away from our conversation so far is like how important it is to build a community. It certainly shows up with even the vector stores that have emerged today. It's really a lot of community that helps make that happen. Maybe you have a good advice for entrepreneurs in general. And I was wondering, maybe as we close, what advice you'd give entrepreneurs in the generative AI space beyond the community? What are the things that we should be doing to succeed?
It's tough. I mean, I would try to not jump into the space right now. That would be my thing. And the reason why I say that is to scare you, because it's really really hard to stand out and to raise funding. It's very noisy. And there's going to be some who will say, I'm just going to do it anyways because I have this thing I really have to do. And that's the right reason to go do it. But I feel like a lot of people are jumping into the space because it's hot and it's interesting, it's fun to build. But that's not necessarily a recipe for building a company. You have to have a real problem. And if you look at a lot of these startups who've raised considerable capital, a lot of them have struggled. Some of them have hit 10 million ARR and now they're plateauing and they're sinking now. There's a lot of churn on the back end where companies get excited and use it and then they don't really use it anymore because it didn't really satisfy their requirements. And so you almost want to wait and see what, where the skeletons lie and learn from that and then build in the right area. And so if you can, be very patient. And if there is something that's burning in desire to go build, then hopefully that's rooted in a problem that you really need to see solved. And then you should go about and doing it. But I would really try to bite your lip and not try to do a startup in this space. I think it's extremely challenging. I think the other thing is, if you look at what VCs are doing, a lot of VCs, interestingly, are hiring like these PhDs out of these grad schools, like really deep learning folks to come on site and help them get educated on the space. And I think it's also because, and you were mentioning this, like there's like a new Arvix paper like every day. Like there's it's almost impossible to keep track of all the new developments that are happening. And so the VCs are in a similar boat, and they're seeing that a lot of the new companies are getting built, the ones that are getting a lot of traction, are built around some new cool concept coming that's very technical, that's a little bit deeper. And a lot of those things come from academia, right? And I think staying close to academia, similar to how VCs are trying to get closer to academia, is probably a wise thing. Because you want to have something that's a little bit more defensible. Things that come out of academia can get open source and then become a community, which is the stuff we were talking about earlier. So it just all kind of jives really nicely. You can find really good talent there as well to kind of build with. So yeah, I think all my advice is very opposite of the advice I would have given to someone in 2010. So I'm basically saying, look at big companies for inspiration, go back to academia, learn from what they're doing, stay close to people there, be nice to your professors, and hold off on starting a company unless you have everything right, because the space is extremely challenging. And I think we're probably a year or two away until we actually see real clear product market fit and winners in the space that you can go and replicate and model from.
That's awesome. I am definitely making my grad students watch this video. Academia is the future. Well, thanks, Vik, for joining us, and I look forward to seeing what you do next.
No, thank you for having me.